Okay, I think it's time for us to start. Good day to everyone, and thank you for joining us today for Tekla Wednesday webinar from Trimble. I'm your host, Toni Kamala, and it's my great pleasure to introduce our today's webinar speakers, Mr. Matthias Lange and Mr. Patrick Lenga from LAP Laser, and of course my Trimble colleague, Sten Durak. In today's webinar, we will focus on integrated workflow between Tekla structures and LAP's industrial laser projection systems. Just quick word about the LAP. LAP is a manufacturer of high precision measuring systems for different industrial sectors. And Patrick will talk about this more in detail shortly. Overall today, Patrick and Matthias will talk about LAP's solution for companies producing precast. And of course, we will also talk a bit about Tekla structures, and Sten will show how fabrication data from Tekla model can be transferred to LAP systems. Before continuing, I urge you to close all other applications, then go to webinar and view in full screen mode. And please note that questions and answers will follow the presentation. Questions can be submitted at any time, but we will address them at the end. As is usual, the webinar is being recorded, and our aim is to post the recording this Friday latest. And the recording can be found on our Wednesday webinar page at tekla.com. But okay, now let's move to today's topic. In today's webinar, our aim is to present how model-based working with Tekla and linking model information to LAP's laser projection systems can help to prevent errors and streamline the precast production. And basically on this slide, you can see kind of summary of the workflow we are talking about today. So with Tekla structures, the detailed model of building is created, and from model we can generate drawings and other documents for the production and erection purposes. For those who are new to Tekla structures, I'll come back to this part more in detail shortly. From Tekla model, fabrication data can be transferred to LAP systems, and we can use file format called Unitechnic to do this. And with Labs LAP solution, data exported from Tekla model can be taken in use at factory to benefit production of precast elements. If we take a short look at what is planned to be presented today, we begin with the presentation by LAP. Patrick Lenga from LAP US will present LAP as a company and talk about their solution for the precast fabricators. And after this, we go through a bit about Tekla structures, what is modeling with Tekla. We'll talk about Tekla's compatibility with other industry software and how to transfer data from model to precast production systems like LAPs. We also go through a bit what is Unitechnic file format, what is included in data file, and when it's created from model. And after the presentations, we will have demonstrations of overall solution by Sten and Matthias. And of course, at the end of the session, there will be a place for questions and answers. But now, I'm happy to welcome Patrick Lenga from LAP US. So let's transfer our broadcast to different place. So please, Matthias. Sorry, Patrick, stage is yours.
Thank you, Tony, for the introduction and for the warm welcome. Dear seminar participant, my name is Patrick Lenga. I am based in the LAP office in Cincinnati, Ohio, USA, being responsible for sales of LAP industrial laser product in the Americas. Today, I will provide you a brief overview on LAP as a company. I will also introduce our CAD-PRO solution, our laser projection system for the production of concrete prefabs. In 1984, LAP, being pioneers in laser technology, started to develop point and line laser units for industrial measuring systems. Today, LAP Laser Applikationen is an ISO-certified company providing quality laser solution to the global markets. We are active in 3 business areas, offering industrial laser projection, laser measurement, and healthcare solutions. LAP headquarters is located near Hamburg in Germany, and the LAP staff takes care of the company's worldwide customers through subsidiaries in the USA, Singapore, and China, as well as a network of more than 70 distributors worldwide. The focus of our business is to improve process, performance, and to assure quality within manufacturing lines. LAP offers a complete range of laser projection product for industrial use. We can project everything from laser points to lines, crosses, fast-moving lines up to free shape on most 3D surfaces. We offer line lasers in different power classes with different optics and different laser colors. All product being well suited for the harsh environment of industrial use. We offer several different sizes of servo lasers with up to 2,600 millimeters or 8 feet moving range and moving speed of up to 1,000 millimeters per second or 3.2 feet per second. Customer can select flexible configuration with red, green, blue laser module, adjustable in power, and fully controlled by PLC via standardized Ethernet IP control. Furthermore, we offer laser projection system consisting of advanced laser projection, functional reflector target, and a user-friendly remote control, and the feature-rich ProSoft projection software. All of the products are built to secure long lifetime and reduce service requirement. LAP laser projection products are being used in various industries worldwide, from tire manufacturing to rubber stone to concrete, aviation, and automotive. In the following section, I will focus on LAP laser projection system. LAP laser projection system is called CAD-PRO and consists of one or more CAD-PRO laser projectors, laser targets, and the user-friendly ProSoft software, and one or more remote controls. The LAP laser projector displays precise outline, templates, patterns, or other shapes on almost all surfaces. The laser projection is thereby based on CAD data provided by the customer. Changes on the CAD data can easily be implemented. However, one has to mention that certain data preparation work always has to be performed for laser projection. The projection surface may be flat 2D or curved 3D. The LAP projection system secures a correct positioned laser image of the CAD model line on the surface. The laser image of the CAD-PRO model can then be used by customer to join parts, place layers of material, align parts, display work steps, control completeness, or support any other work with the help of the visual laser lines. Thereby, laser projector reduce time to production, improve output capacity, and reduce reject, resulting in fast return on investment. LAP laser projection systems are deployed worldwide in many industries, in particular in composite manufacturing for aircraft and wind rotor blades. LAP has created a specific 3-in-1 package to address the need of the prefabricated concrete market. The Concrete Pro package includes everything needed to start the laser projection on static or circulating pallet, and any object placed on those. The projected laser lines are based on your technical drawing in CAD or Unitech file format. The data can be exported straight from Tekla structure software and then be opened in the LAP laser projection software. With Concrete Pro, you can optimize the process sequence and your production quality. In the manufacture of practically all prefabricated concrete parts, you can work faster, more flexibly, and more precisely than with mechanical templates, color plotters, or other aids for measuring and positioning. Utilize projection at the speed of light instead of time-consuming alignment using straight edges angles, or stops. In contrast to plotters, with which you must mark all the operation on the pallet at one time, you can call up on the process projection files on a step-by-step basis using a remote control unit. Thanks to LAP Multicolor, it is possible to project images in different colors for different or important steps in the process. Or you can project the outline of an object onto the pallet in green, and for verification purposes, project the profile of the position element on its upper surface in red. After production of the concrete part, it is no longer necessary to clean the color marks off the pallet, since the laser does not leave any traces behind. Customers report to us fast, simple, reliable, and cost-effective solution that helps them speed up production by up to 25%. The generic setup for CAD-PRO solution is straightforward. The lasers are mounted over the work area. They can be attached to ceilings or beam in a fixed position or to pivot arms or rails so that they can move. The standard industrial PC control one or more laser projectors. The projectors depict the outline individually or simultaneously depending on the customer's specific requirement. The projection displays the shape or major profile segment on a 1:1 scale in the desired work area. The next item to populate the palette can be positioned precisely within the projected outline. In addition to outlines, letters and numbers can be projected. It is also possible to use user-defined signs and symbols. On this slide, I want to show you a real working example of your laser projection system based on 3 pictures. Image 1 shows how a worker in the factory hall uses a laser line for the placement of a formwork module for an opening. Image 2 shows the formwork module, and the green laser line indicates the correct placement. Image 3 shows how the ProSoft UT software compensates for the different height of build in components. I have reached the end of my brief company and solution overview and would like to thank you for your attention. At the end of the webinar and following the demonstration, you will have a chance to address any question related to LAP solution. Thank you very much.
Thank you, Patrick, for your presentation. I think it gave a quite good overview of LAP's offering. But before going to real demonstration, let's talk a bit about Tekla and how data from model can be transferred to LAP software. In Patrick's presentation, it was briefly mentioned how production data can be input to a LAP system. But still, no production data is useful if it's not correct, which brings us to this slide, where I briefly want to talk about what is modeling and data creation with Tekla structures, especially for those in today's audience who are new to modeling with Tekla. What comes to preventing detailing errors and creation of correct, precise fabrication information which is needed, we see that this is one of the key benefits achieved with model-based working with Tekla structures. It bases on accurate models with detailed reinforcements, connections, embeds, and other fabrication information, which can be included in Tekla model. If you talk about BIM terms, Tekla is able to produce models with so-called level of development 400 and 500 out of the box. If you are not familiar with the term level of development, I would like to guide you to check our webinar from last December, where we talk about this more in detail. The webinar is available on our webinar page at tekla.com. But talking about preventing errors, another aspect of this is the way how modeling with Tekla is done. Thanks to unique technology for managing model and related data, our users can work in whole model of building, not just in a separate sections of it, which all helps to ensure that everything fits together. And also utilization of general collaboration formats like IFC enables to share reference information between different design parties like architects and MEP designers, and the combination of combining models. With combining models, it's easy to make necessary changes to a structural model and make sure that there are no costly surprises later in the project. And when talking about the drawings, with Tekla, basically the model is the source for all building information and different drawings, different reports, and other documents needed in the process. Basically, you ensure that model is correct, and then all the information in different documents which are generated from the model is correct. And it's consistent because basically the source is the same. And in project changes, you make necessary corrections to the model, and changes can be updated to all relevant documents. Of course, Tekla comes with ready-made templates, but users can customize their own according what is needed. For example, creating rules for different drawing views and how drawings of different element types should look like helps to standardize and streamline the drawing production. On this image here, you can see one example of customized fabrication drawing, which can be created with Tekla. Traditionally, it might be that cast unit drawings are created in a way that all information is put on same drawing, on same sheet of paper. But when we think from the production process point of view, it might be beneficial that everybody in production chain do not necessarily need all information. And one way to make drawings a bit more clear to read is to separate drawings to a certain working steps, and show only information which is relevant for person reading the drawing. So if we take an example, a group responsible of reinforcements have drawing with only relevant information for them, and a group who is building the shuttering, installing embeds and other concrete inserts, and in today's topic, group using LAP laser projection systems, this group will only have information relevant for them in drawings. So like this, the drawings will be more clear to read. Basically, customization like this can be done centrally in company by one person, and templates created can then be shared to all detailing teams. And one way to share company-specific templates like this is by using Tekla Warehouse. And in addition to just drawing information, it's possible to create separate models of individual cast units. By using file format like IFC, model files can be utilized with Trimble's mobile tools like Tekla Field 3D, which is a mobile solution easy to learn and does not need any special computer skills to use. And Tekla Field 3D can be used on devices like tablets and mobile phones. And especially with the complex elements, easy to read 3D information helps to understand how the element should be built, which might be difficult just by using drawings. But it's not, of course, only about drawings and models. Concerning today's topic with LAP laser fabrication information from Tekla can also be sent to a different production systems in digital form. And also talking about Tekla's open system approach, addition to expanding data, exchanging data with different design software, data can also be sent directly from model to a different production management systems and ERP systems. Some examples can be seen here. But more importantly for today's topic, Tekla is compatible with all leading production systems, and data can be exported from model to production machinery simply by using industry file formats like, for instance, Unitechnic and PVPS. This slide and image here it's quite busy, and I guess details it's a bit hard to see from this, but just to give an example, PVPS is general file format used to send data to rebar bending machines and different rebar production management software. And the Unitechnic is format used, for example, by automated mesh welding machines and different master computers, which are used to control shuttering robots, concrete distributors, and pallet circulation systems, and so on in automated production plants. Generally, there are some other file formats also used by different automated production systems, which Tekla is fully able to produce, but that's topic for some other presentation. But regarding the Unitechnic file format, like mentioned earlier, this is the file format which is also used to transfer data from Tekla model to LAP's systems. So basically, detailed model, we have all the data, all the information needed to produce the elements, and with model, it's easy to ensure that there are no clashes, everything fits together, and data is correct. And from Tekla, we create Unitechnic data file for individual elements and transfer those files directly to LAP's software. And Sten will show shortly how this is done. But before going to this, I like to mention some words about Unitechnic. And if we start with the question, how it is possible in one and same concrete precasting plant that equipment from different manufacturers can be combined with another? Or why is it that laser is able to separate different parts and objects in precast panel and show outlines, recesses, and on-built components in different colors or different sequences? So really to be able to do this, there is a common language needed so that the plant and system components like detailing software, shuttering robot, mesh welding machine, or like in today's case, laser, all from different manufacturers can communicate together. And this language was designed by the company called Unitechnic around the end of 80s. So addition to name of the file format, Unitechnic is also a name of the company behind it. And here you see a simple representation of data file and what it contains. So in Unitechnic file, there is information about element outlines, recesses, and openings included. And this information can be sent automatically to a laser projection system. And in addition, position for different embeds and reinforcement information can also be included to data files. And here again is one visualization. Production file content is visualized with a Unitechnic viewer, which can be used, for example, to check the file content. But okay, let's see how this workflow actually looks like. We'll start with Sten demonstrating Tekla structures, how data is created, and how Unitechnic file is created and transferred to from Tekla to LAP software. And then we move to a LAP's part. Matthias will demonstrate how laser projection system can be controlled with LAP software and shows a bit how laser outlines looks like. But we start with Sten, so please, you are free to start your demonstration.
Thank you, Tony. So I will give you a small demo about how Tekla structures works here and how do we get these Unitechnic files from the Tekla structures model. So we have here 4 buildings where we will find one inner panel, that's the wall panel, that's a little bit easier to the use for the demo. Here, for example, we can find one panel with this one opening. Let's start with, for example, doing the horizontal wall connection. From the component catalog, we search for the component, select the component, load the settings, apply them, and now we just select elements between these elements we want to have the connection, and also the location. From here to here we would like to place the, and now we have the horizontal connection quite nicely, this wall shoes and connection between the foundation. So let's take a closer look of this wall panel, create the 3D view. Here we have it. So we redraw and see that this element already has all the shape, all the openings, and the openings are filled with green styrofoam. This is for the fabrication purposes. Also we have here these horizontal connection elements, the wall shoes, and also for the vertical connection elements for connecting with other wall panels. And for the transporting or lifting, there is the lifting anchors. So let's add some reinforcement also. Let's start with edge and corner reinforcement. Select the component again, the settings, apply and OK, and then use them. So here we can see that the edge reinforcement is placed quite nicely, and let's add some mesh bars also. Select the mesh bars. Again, the settings, apply OK, and the element. And here we have the mesh bars. Really quick demo also about adding the embeds. Let's add a steel plate here. Here we can quite easily choose the location, rotate it, later on move it also, and here it is. And now also let's add to this a sub assembly to this cast unit. So one thing more before start exporting, we have to number the elements. Start numbering and number the elements. Now once we have finished the numbering, we can select the element and file, export these to Unitechnic file. So everything looks good. Just in case, let's load the settings, apply, create. Here we can see parts exported successfully. And now there is always, we send also the drawings. So let's select the element and create cast unit drawing. And now here it is. Let's open it. So here we have the drawing that we just created. Here's the formwork with all the measures. Here is the reinforcement with marks, bar bending schedule with all the rebars, material list of the quantities, 3D views. So let's make a quick drawing also. Print PDF looks okay. Print close. And now let's see how it came. Plot files. The PDF is here, and now the Unitechnic file also. Yes, this is the one. And let's send it to the LAP laser software that will take care of this file. We'll use it from here on. So thank you.
Okay, thank you, Sten. We'll change some computers here. So next will be Matthias in Germany. So here you go.
Thank you, Tony, for providing the data. Welcome to the presentation of LAP laser projection. I will show you now how you can handle the data with the projection software and what the laser outlines will look like. As we don't do the webinar in a real concrete casting facility, I will show the projection on the office wall. Like always, you start the software with a double click. Our software is called ProSoft UT, the projection software for Unitechnik files. It provides the data for the laser projector namens CAD-PRO or CAD projector. Several projectors may be controlled by the software for covering large areas. The basic structure of the desktop is quite easy to understand. Top navigation and menus like you know from other Windows applications. In the center you find the display area. And on the bottom we have some control elements. I will now open the file that Tony sent to me. As you see in the display, the correct data has been selected. You know the shape from the presentation before. In real life, you would have calibrated the laser projection system first. That's where the 4 reference marks in the display come from. And the palette for the production of this element have been placed in the projection area. On the lower left side, you can see the file structure as a tree. If you place the mouse pointer over it, you get the information concerning single elements shown in a pop-up window. Right beside it, you can select which elements should be shown. As you see, contours and cutouts have been checked. This is what you see above. The laser projection would look like this. If you check further boxes, the related content will also be shown. But this gets too complicated for working. In reality, you will display what is needed for the next work step, like starting with the cutouts. Showing the reinforcements next by selecting rod stocks horizontal and rod stocks vertical. The laser will not show the complete steel mats as you have seen in the picture. Only the beginning and ends of the rebar. The length of the beginning and endings can be defined in the initial configuration menu. If you enter a different value here, the start and end of the rebar elements will be longer or shorter. Please keep in mind that too long elements will make the projectors flicker. If you have to place single elements, it may even make sense to project vertical and horizontal parts separately. For prefabricated mats, you just need short markers anyhow. Back to the work steps. At the end, you maybe want to outline the mounting parts. The order of the shown elements depends on the production process. It may be different from case to case. At the bottom right side of the user interface, you can see the object height. If you project on the empty palette, this should be standard value for your factory setup, typically 0. The value may differ if you place something higher above the palette surface. Normally, this should be defined in the data file. But there may be situations when you want to display the data of a certain height. One example is placing braced girders from projection on top of the girders. Clicking on Change Object Height allows you to enter the height of the girders at the new set value. You may show the actual height by activating the Height A button in the top row. I zoom in the picture to see what will be projected. If the girder height is determined and needed regularly, you may define buttons for recurring heights in the settings menu. Open the settings, configuration, standard heights. Here's one button with 120 millimeters. Now we have a new button for calling 120 millimeter height directly. So the selectable height is shown on mouse over. Now the height is activated and the height display shows 120 millimeter. Last but not least, we have the possibility to change the Y offset. This comes in handy when you produce double walls. If you turn over the dried part of the wall, you need to be placed exactly over the wet part. Sometimes the tiling works not as precisely as required. With the Y offset, you may move the projection to guarantee that openings for windows on one wall exactly match the openings in the second part of the wall. Before I close my session, I would like to mention that the workers can interact with the laser projection system using the portable remote control. You don't need to enter each work step at the keyboard. Our time in this webinar is limited, so I can't show you all features that support your work. We would be happy if you come back to us for more information. For today, I say thank you for watching and back to Tim.
Thank you, Matthias. Playing with my sound controls here. Unfortunately, we were not able to show a demonstration of actual laser in use. It's a bit difficult to demonstrate and show laser lines in a webinar, but I hope that you got a good understanding of how LAP's laser projection system works and how visualization can be controlled by a user at the factory environment. And I hope that you got an idea how fabrication data from model can be transferred to a LAP system. That was the last part of our webinar today. Before going to questions, I would like to use this opportunity and mention that especially for those who are close to following two events, Betontag in Germany at the end of February and Precast show in Nashville, US, beginning of March. Both companies, Trimble and LAP, will have a booth in the events, so please reserve the date and come and have a chat with us. And you will also, at those events, you are also able to see both solutions live and have a chat and discuss more in detail. But now to questions. We have got some questions during the webinar, and I will show those to you shortly. If you still have questions on today's topics, please submit them to us by using questions dialog box. And you can, of course, also always send questions later on by email at tekla.webinar@trimble.com. Please notice the address is changed from previous webinars. But now to the first question, I think let's take these two ones. These are quite similar, and this comes to Sten. Can I export all elements with one Unitechnic file, or do I have to do it one by one for each element? So Sten, if you can answer to this.
Okay. First of all, Unitechnic file format itself can include information about only one cast unit, and that's why every cast unit has to have different file. But don't worry, with Tekla structures it's not a problem, because you can export entire model or only selected elements with one go, so you don't have to do it separately. And for selecting elements, you can choose or pick the elements manually from the model, or also you can use our really efficient tool organizer that helps select the needed organized elements quite quickly and efficiently, and then export them as separate files.
Okay, thank you. And next one is also relating quite same topic. Does all the information from model go to Unitechnic file, or can we exclude, for example, some embeds or rebars?
Yes, we can exclude, for example, embeds or rebars or meshes, and there are quite many different options to choose what and how we want to export these Unitechnic files. Although there are many settings or options, we don't have to set them every time. We can just use the pre-saved settings.
Okay, thank you. And I think next one will go to Matthias. This is relating to LAP. What are the errors most commonly made when using laser together with CAD data? How to avoid those? So Matthias.
Each installation has an individual environment and individual processes. Still, we often encounter discrepancies in the measurement data of CAD data of the objects we project on. If the palette rim or surface or the calibration marks are not positioned where the CAD data says they should be, the whole projection can't be precise. So, accurate measurement and correct data are essential.
Okay. Thank you. And the next one also, I guess this is the one which I sent you already earlier. Matthias, how can a projector failure be handled?
Laser projectors can't be repaired on location. If you have a spare projector on site, you just change it. Switch off, disconnect cable, open bracket, change projector, aim system at workplace, close bracket, connect cable, switch on, recalibrate, and work on. Done nearly as fast, I'm telling it. Then you chip the defect projector to LAP and receive it back as soon as possible. If you have no spare projector, you contact LAP and ask for a temporary replacement. We will send it out as soon as possible. After contacting LAP, you can dismount the defect projector and send it to LAP.
Okay. Thank you. That I guess this was quite straightforward. Let's see. I think we have a time for one question still. But before continue, I would like to remind you again that you can also send us emails and ask questions. Address is tekla.webinar@trimble.com. I know that we haven't answered all the questions which we have received, but we will get back to you via email as soon as possible, tomorrow latest. Also to mention, at the end of the webinar there will be a short feedback poll, 3 short questions. We would be glad if you would take a few seconds to respond to these. And still before the final question, next webinar preview. In the first week of March, we have a series of webinars coming up. It's time again for sneak previews for new version of Tekla Structures. Starting on Tuesday, 1st of March, we have a set of 4 different webinars introducing latest developments of Tekla software. Great new things will be introduced with new version. So please go and check out our webpage. More information about the content is already available at webinar page at tekla.com. But to our last question, I think this will go again to Sten, and it's about the drawings which we saw on the presentation. Drawing example which you showed with 4 different drawings created. Will this type of drawing create 4 different drawing files? So Sten.
No, it will create only one file where we can have all drawings on different pages. And all drawings have the same drawing number but each page has its own page number, so we can make the difference of the pages, and also you know which sub-drawing belongs together when you print the drawings out.
Okay, thank you, Sten. Just going through the questions, there are several of those relating to steel, relating to the customers. Yes, there are steel applications available, and yes, there are customers in the US using it, but we will come back to this to you with the answers, more proper answer in via email. Now we have to end this webinar today. I think we have used our time. So all our listeners, thank you for being with us. Thank you, Matthias. Thank you, Patrick. Thank you, Sten. And all of you there, goodbye till next time.